Because it's one of the most powerful exploit frameworks and it has a free version with a wide functionality, we're going to use Metasploit throughout the course. Metasploit project is the most used penetration testing framework in the world. It can be used to test the vulnerability of computer systems or to break into remote systems. As I mentioned before, Metasploit was created by H.D. Moore in 2003 using Perl. By 2007, the Metasploit framework had been completely rewritten in Ruby. In 2009, the project was acquired by Rapid7. Now they have a free and open source version, Metasploit Framework, and a commercial version, Metasploit Pro. Its best-known sub-project is the open-source Metasploit Framework, a tool for developing and executing exploit code against a remote target machine. The MSF console is probably the most popular interface to the Metasploit Framework, MSF. It provides an all-in-one centralized console and allows you efficient access to virtually all of the options available in MSF. MSF console may seem intimidating at first, but once you learn the syntax of the commands, you'll learn to appreciate the power of using the cd command to go there, and the ls command to see the files and folders inside the Metasploit home folder. So look at this. There are executables and directories, and of course I mean folders here. So note that near the bottom there's a directory called scripts. Now this includes, among other things, interpreter scripts such as hash dump that enables us to gather user hashes of the exploited system. Also note that the executables MSF console, MSF update, MSF venom, and more. MSF venom is the Metasploit's standalone payload generator, and we're going to see MSF console and the MSF update in detail. So let's now explore the Metasploit modules. These are the blood and guts of Metasploit. Use cd command to enter the module's directory and the ls command to see the files. Now, I hope you're seeing what I'm seeing because Metasploit modules. So these include source codes which exploit the vulnerabilities are in the exploits folder. And as I told you before, the payload is the portion of the malware which performs malicious action. The payloads are located in the payloads folder. Encoders inside the encoders folder are the various algorithms and encoding schemes that Metasploit can use to re-encode the payloads. These may be used to bypass the security measures such as IDS, IPS, or firewalls. Auxiliary modules are for a variety of purposes other than exploitation. You can create your own quick vulnerability scanners, port scanners, and do a whole lot of other cool stuff. Modules used for post-exploitation are in a post folder. And as I told you before, the post-exploitation basically uses the exploited system as much as possible. So we can collect more data and compromise more systems in the target network. And here is no operation, abbreviated NOP, modules inside the NOPS folder. Keep the payload sizes consistent. So let's look inside the exploits folder in detail. Again, the cd command to get in, the ls command to look at the files and the folders inside. The exploits folder is basically broken down into subdirectories that are specific to the operating system and device types we're attempting to exploit. For instance, you can see at the top the AIX folder, which contains the exploits developed for IBM's proprietary Unix operating system, and the multi folder contains the exploits which run in cross-platforms. So, drill down further into the exploits folder. I want to go to Windows, ls to see the folder details. Now we can see that the Windows exploits are broken down into types of Windows exploits. It's important to note that the exploits are very specific. Not only are they operating system specific, but also application or service specific, port specific, and sometimes even language specific. So let's look inside one of the subfolders here. I'll choose the SMB folder. And here are the exploit codes for SMB service, psexec, for example, one of them, which we will be using in this course. So now let's turn back to the modules folder. Now, I'd like to show you the payloads folder. Now, if you can see here, the payloads are grouped by the types, singles, stages, and stagers. We'll talk about them in the following lectures. Now let's see what's inside the subfolders, for example, singles. And once again, we can see that the Metasploit framework categorizes the payloads by operating system and device types. I'll go to the generic folder and list the files and folders with the ls command, and here are the source codes of the generic payloads. Actually, Metasploit framework is already in Kali's path, so you don't need to find the location of it. You can just run it in any location. Type msf update and hit enter. If you run the command inside Kali, you'll see this message. It says Metasploit is part of Kali, so we should use ordinary system update commands. So let's do what it says. Select the command, click the middle mouse button, and hit enter. If you have recently updated, the process will be short. Otherwise, it may take a couple of minutes. Now we're finished, and we are ready to exploit. The MSF console is probably the most popular interface to the Metasploit framework, MSF. It provides an all-in-one centralized console and allows you efficient access to virtually all of the operations available in the MSF. MSF console may seem intimidating at first, but once you learn the syntax of the commands, you will learn to appreciate the power of utilizing this interface. Here are the benefits to use the MSF console. It's the only supported way to access most of the features within Metasploit. It provides a console-based interface to the framework. It contains the most features and is the most stable framework interface. It has full readline support, tabbing, and command completion. And execution of external commands in MSF console is possible. For example, you can use ping or ifconfig system commands while you are inside the MSF. Its IP address, and an up-to-date Windows 8 with an IP address of 223. So now I'll go back to Kali and ping the other systems just to make sure they can access each other. So ping Metasploitable first, 206, and it replies. Now the XP system, 207, it replies to. What about the Windows 8, 223? Yep, it replies as well. Now, let me tell you, in some Windows 8 installations, the system might be closed to reply ping requests. For example, if you choose a network as a public network, Windows 8 probably doesn't reply to your ping request. But no worries. Just go to the Windows 8 or the up-to-date Windows system you use, for example, Windows 10, and ping Kali in it. Kali replies ping requests by default. So you should see the replies of the ping requests here. No packet loss, all my systems see each other, and I'm ready to fly. If you have any problems here, please just go back and check the networks of the systems once again. They should have the same network mode, bridge, NAT, or host only. They should be in the same subnetwork, for example, 192.168.1.x, modules, and numbers of payloads, encoders, and NOPs. The first command that you should learn in MSF console is, of course, help. The help command lists all the commands you can use at this point. I do say at this point because any module you load may add some new commands you can use. But we'll see soon, and I'll let it go for now. As you can see, the commands are grouped. Here are the core commands, module commands, job commands, resource script commands, and credential backend commands. Now, to search for a module you want to use, for example, exploits developed to exploit Net API vulnerabilities, you can simply use the search command with a keyword. And here are the results. Exploits for several Net API vulnerabilities. The first one is to exploit the MS03-049 vulnerability, and we have 4 exploits for 4 different Net API vulnerabilities. Now, you can see the columns, name of the module, disclosure date, rank, and description of the module. Since the names of the other columns explain themselves, let's talk about the ranks. In Metasploit framework, the exploits are ranked to help us select the appropriate exploit. Here are all the ranks and their meanings. Starting off with excellent. The exploit will never crash the service. This is the case for SQL injection, CMD execution, RFI, LFI, etc. No typical memory corruption exploit should be given this ranking unless there are extraordinary circumstances. Great. The exploit has a default target and either auto-detects the appropriate target or uses an application-specific return address after a version check. So good is that the exploit has a default target and it is the common case for this type of software. English, Windows 7 for desktop app, 2012 for server, etc. So normal, this exploit is otherwise reliable, but depends on a specific version and can't or doesn't reliably auto-detect. Average, the exploit is generally unreliable or difficult to exploit. And low, the exploit is nearly impossible to exploit, or under 50% success rate for common platforms. And manual, exploit is unstable or difficult to exploit and is basically a DOS. This ranking is also used when the module has no use unless specifically configured by the user. For example, exploit/Unix/webapp/ vulnerability scanning. And you'll certainly remember that there was an exploitable vulnerability in the Java RMI service of the Metasploitable system. So let's exploit the Metasploitable. Here we are in the MSF console, so you can use the search command to find the exploits for Java RMI server insecure default config vulnerability. Here we find 2 auxiliaries and 2 exploits. To use the exploit, we use the use command of MSF console. Give the full name of the exploit you see. And you see the command prompt shows us which exploit or auxiliary that we are using. Now we can select a payload, type show payloads to see the payloads available with this exploit. You're going to see different payload lists, different exploits, but we have to choose one of these payloads. But you know something? I'd like to pause here for a bit for a little bit of definition. Sorry for that. I know you're chomping at the bit, but I'd like you to understand what it is that you're actually doing. So there are 3 different types of payload modules in the Metasploit framework: singles, stagers, and stages. These different types allow for a great deal of versatility and can be useful across numerous types of scenarios. Whether or not a payload is staged is represented by / in the payload name. For example, Windows/shell bind TCP is a single payload with no stage, whereas Windows/shell/. consists of a stager, reverse TCP RC4, and a stage shell. So singles are payloads that are self-contained and completely standalone. A single payload can be something as simple as adding a user to the target system or running calc.exe. These kinds of payloads are self-contained, so they can be caught with non-Metasploit handlers such as Netcat. Stagers set up a network connection between the attacker and victim, and are designed to be small and reliable. It is difficult to always do both of these well, so the result is multiple similar stagers. Metasploit will use the best one when it can and fall back to a less preferred one if it's necessary. Stages are payload components that are downloaded by stagers modules. The various payload stages provide advanced features with no size limits such as Meterpreter, VNC injection, and the iPhone iPone shell. Okay, so where were we? Right. We were about to set the payload for our exploit. To use the payload we want, we use the set payload Metasploit command. And look at that, you'll see that there are two popular types of shells, bind and reverse. A bind shell is the kind that opens up a new service on the target machine and requires the attacker to connect to it in order to get a session. A reverse shell, it's also known as a connect back, is the exact opposite. It requires the attacker to set up a listener first on his box. The target machine acts as a client connecting to that listener, and then, finally, the attacker receives the shell. So here I want to use the Java/shell. Type show options to see the parameters we have to configure. Now these are the parameters of the module, and these are the parameters of the selected payload. Required field shows if you have to fill in the parameter or not. If the option is required, it cannot be empty. So let's set the options for this exploit. Module options first. The first option is HTTP delay, which indicates the time that the HTTP server will wait for the payload request. It has a default value, 10. Just leave it as it is. rhost is the remote host, which means the target machine. In this example, Metasploitable, set rhost with the IP address of Metasploitable. Rport is the target port. As we've seen before, Java RMI service port of Metasploitable is 1099, which is the default value of the option. Serve host is another required field, which stands for the local host to listen on. Kali for us. So set serve host with the IP address of Kali. Serve post is another required field, the local port to listen on. And that has a default value of 8080. No need to change the default here. So the last three options are not required, so I'll just let them be with the default values. Now, let's set the payload options. Because it's a reverse shell payload, it asks the listener host's IP address and the port. Both of them are, of course, required. So set the L host, the listener address, as your Kali, and if you'd like, change the default value of the listen port. 4444 is fine for me. Now we are ready to run the exploit. And here you can use either run or the exploit command. Okay, so what the heck happened here? Let's look at the messages given by Metasploit. This module takes advantage of the default configuration of the RMI registry and RMI activation services, which allow loading classes from any remote HTTP URL. Here, it tries to exploit the vulnerability which is on the service running on the port 1099 of Metasploitable, using the application running on the port 8080 of our Kali. And finally, it says a command shell session opened, which means exploitation is successful. Now, because we don't need the HTTP server opened in Kali anymore, it's stopped at the end of the exploitation. Sessions command is used to see the session running in the background. We'll see the session command in details. Type session L to see the active sessions and sessions I1 to interact with the session which has the ID number 1. I think the interaction is started with the ls command, and we now have the shell for Metasploitable. Print working directory, we are at the root. Who am I? We are the root user. If config to learn the IP address, etc. So because of its importance and strength, Meterpreter deserves to have its own private section. Meterpreter, it's short for the Meta Interpreter. It's an advanced payload that is included in the Metasploit framework. Its purpose is to provide complex and advanced features that would otherwise be tedious to implement purely in assembly. The way that it accomplishes this is by allowing developers to write their own extensions in the form of shared object DLL files that can be uploaded and injected into a running process on a target computer after exploitation has occurred. Meterpreter and all of the extensions that it loads are executed entirely from memory and never touch the disk, thus allowing them to execute under the radar of standard antivirus detection. So let's start up a Meterpreter session. Go to Kali, open a terminal screen, and run MSF console. Let's exploit Metasploitable once again, using the Java RMI server insecure default config vulnerability. Now, because we have seen all these before, I want to keep it quick. Search and use the exploit. And now is the time to choose the payload. Type Show Payloads to see the available payloads. And here are a couple of Meterpreter payloads. I want to use Java Meterpreter Reverse TCP for this example, so I use the Set Payload Metasploit Framework command with the payload name. Type Show Options to see the options to set. First, the module options, which we already know. Set our host. Serve host. Leave the R port and serve port as it is. And now here are the options of the Meterpreter Reverse TCP payload. And as you see, they are not different from the reverse shell payloads options. So because it's a reverse connection, it requires the listen host and the listen port. Set the L host as our Kali and L port. If you'd like to change, I don't need to change it, so I'll just leave it there. And now type exploit to run the exploit. It succeeded. Use sessions L to list the active sessions and sessions I with the ID of the session that we want to interact with. Now we have a Meterpreter session. Congratulations. So I want to run one of the Meterpreter sessions now, sysinfo, to check if I exploited the correct system. And there it is. Yes, I'm in Metasploitable. Windows and Linux Meterpreter sessions. This is why I'd like to show you the Meterpreter session in both machines. In our last lecture, we had a Meterpreter session on Metasploitable Linux machine. Let's continue to see the basic Meterpreter commands on that session. So a good habit to get into is looking at the sysinfo, which is the first command that I run when I interact with a Meterpreter session, just so I can see which system I am in. Never hurts to double check. Okay, I'm on Metasploitable. Help is the second command I'd like to show. And not surprisingly, it shows the available commands in this Meterpreter session. Commands are grouped, and we'll talk about it more in the following lectures. But the command names are at the left-hand side, and the descriptions of the commands are on the right-hand side. And here's another command group, anyway. So, first of all, let's see how we can manage Meterpreter sessions. If you're in a Meterpreter session, you can go back to MSF console with the background command. And now we're on MSF shell. Sessions L is to list the active sessions. Now the sessions may or may not be Meterpreter sessions, but you'll see the session type in the third column of the sessions list. In fact, the sessions command with no parameter lists the sessions as well, so you don't need to use the L parameter. The first column of the list shows the ID numbers of the sessions. The information column shows the user and the system connected, and the connection column shows the attacker and the victim system's IP addresses and the connected ports. Use the sessions command with the I parameter to interact with any of these sessions. Simply give the ID number of the session you want to interact with. And we're in the Metinterpreter session of the Metasploitable Linux again. Now, to see our current position in the target system, we'll use the pwd command. Okay, if you're familiar with the Linux system, you already know that the command is a standard Linux command to print working directory. Well, you're wrong. Here, it's a Metinterpreter command, and it runs under the other operating system sessions as well, which I'll show you in a couple of minutes. The Metinterpreter file system commands are mostly similar to the Linux file system commands. We're on the root folder. We can use the ls command to see the files in this folder, the cd command to change or to move to another folder, for example, etc., and now we are in etc folder. So we can use the cd command to go back to the root folder again. The next command is getuid. It's used to show which user you are on that system. We are the root user, which is very good for us, but not for the victim. getPID is to see the ID number of the process that we are injected into, but it seems it's not available on Linux systems. Okay, I'll show it on a Windows system soon. Stay tuned. The PS command is to see the running processes on that system. So hashdump is a very useful command for ethical hackers. As you might guess, it lists the hashes of the user of this system. But remember, you can access the hash files if you have the root or the admin privileges. Otherwise, Metinterpreter cannot gather the hashes. But don't worry, there are a few tricks up our sleeves to escalate the privilege. Well now, it seems Metinterpreter does not have the hashdump command for Linux systems. But again, no worries, because we can use a post module to gather hashes. We'll see that in detail in the post exploitation lecture. So, just to show you that we have alternatives, let's run this post exploitation module. Run post /wind, no, not Windows, it's a Linux system, /gather/hashdump, and hit enter. Remember, Metasploit framework and Metinterpreter have code completion, so you can just use the tab key to complete the words. And here are the usernames and the password hashes. Now, I don't know if I need to stress to you that this is very important data, so we'll use these hashes for some of our purposes a little bit later. But first, let me show you that idle time is another useful Metinterpreter command, which displays the number of seconds that the user at the remote machine has been idle. If you'd like to log out the user or restart the system for any reason, you had better look at the idle time first so you understand if the user is using the machine at that time or if he or she is away. And again, it seems that the idle time command doesn't work for the Linux systems. So I'll show it to you for the Windows system. ifconfig command displays the network interfaces and addresses on the remote machine. Alternatively, ipconfig does the same thing. So Metinterpreter also has the commands to interact with the local file system. Now, because you're on the Metinterpreter session in the terminal window, you don't see the current position by default. So you want to use the lpwd command to see the local position. Think of it as the abbreviation of local print working directory. And to change the local position, you can use the lcd command. And double dot brings us one folder out, and give the path you want to go to as a parameter of the LCD command. Now, as you know, search command is used to look for the modules in a Metasploit framework console. In Meterpreter, the search command has a completely different purpose. It provides a way of locating specific files on the target host. The command is capable of searching through the whole system or specific folders. Wildcards, such as star, can also be used when creating the file pattern to search for. So give the file name with the F parameter. It'll find it and show the position if it exists. So here it is. Shadow file is under the etc folder. Now, don't fall into the trap. This is LPWD command, so it shows the local position. And we can use the cat command to see the content of the shadow file. And here are the password hashes once again. All right, so lastly, if you'd like to have a shell access to the target machine, you can use the shell Meterpreter command. So the channel is created. No command prompt, but it's okay, we have the shell. To see the list of files and folders, if config to see the IP address. And because we are in a Linux shell, we cannot use Meterpreter's search command to find a file, and type exit to exit the shell interaction. And we're in the Meterpreter. Legitimate to share it with you. I'll search, and if it is legitimate, I'll somehow share the virtual machine with you. So as we've seen in the beginning of the course, this system has MS08-067 vulnerability. So now let's try to exploit the vulnerability and have a Meterpreter session on the Windows system. We're in the Metasploitable Meterpreter session. So send the Meterpreter session background to access MSF console shell. Now let's find the exploit module written for the MS08-067 vulnerability. And we have one exploit with a great rank. That's good for us. So type use and the full module name to use it. So now let's look at the payloads we can use with this exploit. Wow, there are a lot of payloads. And let's choose this one. Windows/Meterpreter/reverse TCP. And show the options. Now, we have already seen these steps before, so I'll keep it quick. Set the remote host, the IP address of the Windows machine. Listen host is our Kali. Remote port is correct. Listen port, that's okay for me. Ready to run the exploit. And yes, we have a Meterpreter session on the Windows system. And what's the first command? Oh, my first command. And look at that. We are confirmed. We are on Windows XP Service Pack 1. Help command is the second one, of course. Shows the commands available. Okay, so now there were a few commands which I said that I will show you with a Meterpreter session on a Windows system. The #dump command was not available when we were on Metasploitable. Now Meterpreter has this command. Of course, we can also use the #dump post module as well. The #dump command is more important for Windows systems, and I'll tell you why. In a Linux system, looking at the shadow file is usually enough to see the password hashes. However, gathering hashes is a bit complicated for Windows systems. Password hashes are located in the SAM database, and you need to have the key of the SAM database, which is in the system file. Thankfully, we have Meterpreter. We can dump password hashes of a Windows system with a single. You can use either ifconfig or ipconfig commands to learn the IP address of the victim machine. same as the interpreter on Linux. Now you can use the pwd command to see your current location on the victim system. There's no such command in MS-DOS systems, but hey, this is not the command shell, this is Meterpreter. And again, you can use the cd command to change the location. Now the search function has the same functionality, so you can use it to find any file in the victim machine. You can use the cat command to see the contents of a file. And as you know, cat is a standard Linux command, but this cat is not that cat, if you know what I mean. So now I want to show you a Meterpreter command which is Windows specific. Clear EV. This command is used to clear the application, system, and security logs on a Windows system. There are no options or arguments needed. Your activities on the system after the exploitation will leave some footprints, so you just better clean them up. Let's go to the Windows system and look at the event viewer. Well, I don't know its location, so I'll use the search option. And here it is. Here are the log files. And now let's run the clearev command, and it wiped the log files. So turn back to the Windows system, refresh the event viewer, and see, no logs remain. Well, I don't know if you see what I'm seeing, but there is a new record in the security log. Do you see it? I don't know what it is, but it doesn't look like a warning. Well, at least it doesn't contain any clue about who we are. Now, the shell command presents you with a standard shell on the target system. This time, we have a command prompt as well. Now we can use the standard MS-DOS commands. dir to list the files and folders. ipconfig to see the internal IP, etc., etc. Use exit to exit the shell. Now, we couldn't run idle time commands on Metasploitable Linux system, but now we can. And as I said before, it displays the number of seconds that the user at the remote machine has been idle. Very useful info. So we've now seen how to exploit a vulnerability. Now I'd like to show you how you can exploit a system even though that target system has no exploitable vulnerability. You scratching your head? Pass the hash is a hacking technique that allows an attacker to authenticate a remote server or service by using the underlying NTLM or landman hash of a user's password, instead of requiring the associated plaintext password as is normally the case. So this is how that mechanism works. On systems or services using NTLM authentication, users' passwords are never sent in clear text over the wire. Instead, they are provided to the requesting system, like a domain controller, as a hash. Native Windows applications ask users for the clear text password, then call APIs like LSA logon user that convert that password to one or two hash values, the LM and or NT hashes, and then sends that to the remote server during NTLM authentication. Analysis of this mechanism has shown that the clear text password is not required to complete network authentication successfully. Only the hashes are needed. So if an attacker has the hashes of a user's password, they do not need to brute force the clear text password. They can simply use the hash of an arbitrary user account that they have harvested to authenticate against a remote system and impersonate that user. In other words, from an attacker's perspective, hashes are functionally equivalent to the original passwords that they were generated from. The PsExec module is often used by penetration testers to obtain access to a given system that you already know the credentials for. It was written by WinTernals and has been integrated within the framework. WinTernals were established in 1996 and acquired by Microsoft in 2006, and the name became sysinternals. Now, because we're able to use hash values instead of passwords, Metasploit PSExec module is used to perform pass-the-hash attacks. Now, what do we need to use Metasploit PSExec? The following. Target IP. It's also possible to use more than one IP address or an IP address block in Pro version. The username of a valid user on the target system. A password or the password hash of the user. A share on the target system. Administrative shares on a private network, such as a network of a company, are always enabled because the system administrators understandably don't want to visit a computer to manage. And the output of the Metasploit PSExec will be the interpreter session. Well, the output will be the payload we use, but if we have a chance to have an interpreter session, it's better to take the interpreter session. Your system in the scan network and succeeded to activate an interpreter session. Not necessarily, but just, work with me here. So you obtained a valid username and user password hash values. Computer users are prone to use the same password in different platforms. What do? Do you have different passwords for each of your credentials, Facebook, laptop, Gmail, Instagram, etc., etc.? Well, I can't blame you because there are a lot of platforms asking for our passwords. But what if there are other computers which are logged in with the same password? Remember, we don't need to crack the passwords if LM or NTLM authenticate. First, let me ping the Kali system. Okay, no problem on the network. Now I go to the Kali and ping the Windows 8 VM. Now, as you see, there is no response at the moment, but we know that we can ping Kali VM from Windows 8 VM, so there isn't a problem on the network. And we know that Windows 8 VM is alive and its IP address is 223. So let's make a standard Nmap query through the Windows 8 VM. All the ports of the system look like they're filtered because we got no response from any of the ports. So in a typical business or home network, you don't see such computers much because it's a trusted network and, computers interact with each other. In addition, system admins have to manage the systems and they should be able to manage them remotely. Otherwise, life becomes a commuter disaster for them, having to run to each single computer. So my point is there should be some interaction points, such as open ports or shared folders. And now I'm in a Windows 8 VM, so right-click on the network icon, bottom right, and click Open Network and Sharing Center. In the Advanced Settings Sharings window, select Change Advanced Sharing Settings from the left-hand side panel. As you see here, current profile is guest or public, and network discovery and file and printer sharings are closed in this profile by default. This is why we can't get any reply to our ping queries. So we can change these settings here, or the better way is to change the network profile of my VM. I'll change the network profile, so I'll close this window for now. Click on Settings, and then the network icon. Now right-click on the Connected label and select Turn Sharing On or Off. This is how you can change the network profile in the Windows 8 system. If you use another modern Windows system, such as Windows 10, please Google around a bit to find out how to change the network profile there. But here, choose Yes to turn on the Sharing and Connect to Devices option, because this is the simulation of a work network. All right? So let's look at the advanced sharing settings again. And look at that. The network profile is private now, and network discovery and file sharing is turned on. So now I go back to Kali, ping Windows 8, and now it replies to our ping requests. So let's make a standard Nmap query once again. Now we have some open ports which are mostly needed for sharing and remote connections. And it's exploitable. So let's hack that system and gather the password hashes. Okay, so in Kali, let's open a terminal screen and run MSF console first. While the console is starting, I go to XPVM and look at the IP address again. It's 207. So back to Kali. MSF console is ready. Now, since we've already seen these before, I just want to speed through this. I recommend that you perform all these practices each time, so you will be more familiar with the exploitation steps. Search for the MS08067 exploits. Use the exploit with the use command. Set the appropriate payload. And to make password gathering easy, I'll set an interpreter payload. And show the options. Set the required options. Remote host is XP machine. Localhost as Kali. And leave the other options with the default values and run the exploit. Okay, so now we have an interpreter session on XP. And as we've seen before, we can use hash dump function to gather the password hashes. And here they are. What I'll do is I'll copy them and paste them into a text file to use later. Now I open a new terminal and use the Nano text editor to create a new text file to store my hashes. I create hashxp.txt file in a desktop folder and paste the hashes into it. Control and X to exit, Y to save changes, and hit Enter to save as the same file that we named at the beginning. Now I have the hash file on my desktop. To run an Nmap query with OS detection to find the Windows devices on the network. -O parameter is for the OS detection. Top 5 ports to keep it fast. And the target is the entire IP block 172.16.99.0 to 24. And here are the systems on the network. 222 is the Kali itself. Now you see 223 is detected as a Windows system. According to the fingerprints, Nmap says the system is Windows 7, 8, Vista, or 2008. So, okay, 223 is our new target. So let's prepare another Nmap query for 223 to see the open ports. Port 445 is open, and we know that the port is used for SMB file sharing just by default. And if you're not sure about the service running on the port 445, you can run an Nmap query with the SV parameter to run version detection as well. So I'll assume that the service is SMB file share and skip this step. Now here is a critical step. We need to have at least one file sharing on the target system. In general, you'll find that the administrative folders are shared because the sharing of those folders is enabled by default. But let's make sure. To find out the shares of our new target, we'll use Nmap once again. Nmap has a script to find out SMB shares. Now, we don't need to memorize the names of the script. Let's just find the scripts which may help us find the shares. I'll use the locate Linux command to find the location of the Nmap scripts. Now I know the scripts end with .nse, which is the abbreviation of Nmap scripting engine. Now you know too. So let's go to the scripts folder using the cd command. Now I want to list the scripts which are about SMB service. ls-l to list files, pipe to send the output of the ls command to the next command, and grep smb to filter the scripts. So these are the Nmap scripts related to the SMB service. And this one, SMB enum shares, is the script to find SMB shares. So now let's prepare the Nmap query. Script to use the script, and here's the script. smb-snum-shares. Now, even though the script couldn't get the details, it did find the shares: admin $, C $, IPC $, and users. Okay, so let's turn back to MSF console interface at the other terminal screen to try to pass the hash onto our new target 223. Now, the first thing to search for is psexec to find the exploit. So we'll use the exploit Windows SMB psexec exploit module. And now we can set the payload. Don't forget that you can use tab to command completion in MSF console interface. So set the payload Windows. Now I know it's a 64-bit system. Interpreter reverse TCP. Show options. I set remote host as Windows 8 VM 223. I'll set the listen host as Kali 222. You should be already familiar with all these options. So now we see the psexec specific options. The SMB user option is the login username. As I mentioned before, the options are case sensitive, so you can write SMB user with all lowercase or however you want. So I want to try administrator user and its password. So I set administrator as SMB user. I copied the hash value of the administrator user that we gathered from the XP system and use it as the value of SMB pass parameter. List the options again with the show options command. Our port is 445 by default, and we know that the port is open on our target, so just leave it as it is. Share is admin $, and we also know that admin $, is shared on the target, so leave that as it is as well. Okay, so SMB user, SMB password, listen host, listen port. Okay, we are ready to run the exploit. Are you ready? Nope, no chance. The login failed. So we assume that there is not a user with the name administrator and with the password same as the admin password of the XP. But do you want to give up right now? Of course not. As I mentioned several times, humans tend to use the same password in different platforms and systems. Now, come on. There are a lot of passwords we have to memorize, so it's just human. It's normal to use the same password in all kinds of different platforms. So always try the hash with different users if you cannot get the session with the default user. Now I'll try another username, admin, with the same hash. Okay, so I cheated. I already know that the target system has a user with this name. I mean, you get the idea. You don't want to just sit here and watch me try a list of users just in the course. That's for you to come up with. So let's continue. The other options are the same, and run the exploit for admin user. We got an interpreter session, but hold on, just wait a minute. This is not a session from the target system. Look at the messages. Service timed out and couldn't start, and the exploit decides to send the stage to 207, which is my XP system. Now that's interesting. And the interpreter session is opened on 207, not on 223. This is the Windows XP, which we already exploited. So now I'll exit from the interpreter session and look at the options once again to see if I made a mistake. Okay, so no mistake. Everything's fine. So let's run the exploit once more. Are you with me? Look at the messages. It sent the stage to 223, which is Windows 8 VM, our target, and the interpreter session is opened on 223. It seems we succeeded to exploit Windows 8 without using any vulnerability. So let's check this system info using sysinfo on the interpreter command. And yes, we finally have an interpreter session on Windows 8. Not bad though, is it? So let's have a look at the IP address. Well, it is 223 as expected. So now we can perform post-exploitation steps, such as gathering password hashes using the hashdump command. From here, we can crack the hashes or use them to perform further pass-the-hash attacks, etc., but we'll see a lot of post-exploitation methods in detail later on. Right now, I think you get the point. So I'd like to tell you a few more things about the working principle of the pass-the-hash method. When you look at the slide, you'll see two different runs of the PSExec module. The first run is against a Windows XP target, but the second one is against a Windows 8 system. If the target is Windows XP, PSExec module treats an executable on the target, use it to connect to the target, and then deletes the executable. If the target is a modern Windows system such as Windows 8, the PSExec module checks if the PowerShell is available on the target. If it is, the PSExec module uses PowerShell to open the interpreter session. So if you set the target option of the PSExec module to 2, which means native upload, the module will not use PowerShell, even if it is present on the target. But my recommendation is to use PowerShell of the target system to open a session if it's present. Well, you know what? I was assuming that you know what PowerShell is. I'll give you a very short definition for those of you who don't know what it is. To give you a better understanding of PowerShell, I should first define what a shell is. In computer science, a shell is a user interface that gives you access to various services of an operating system. Windows PowerShell is a shell developed by Microsoft for purposes of task automation and configuration management. This powerful shell is based on the .NET framework, and it includes a command line shell and a scripting language.